continue our discussion. In this video, we are going to solve few problems. So here is the first one. Two bodies A and B of same mass undergo completely inelastic one-dimensional collision. The body A moves with a velocity of v1 while body B is at rest before collision. The velocity of the system after collision is v2. Then we have to find out this ratio v1 is to v2. Okay, one thing is here. If you see this symbol, this is a Greek symbol. We call it nu. We call it nu. So, but here I'm saying it v, and this one is v1. Okay, so not to be confused. Now, coming back to the problem. Before collision, let's say this is body 1 moving with velocity v1 and it has mass m. This is body 2 which is at rest and mass of this body, okay, both are of same mass, so m. After collision, what happens? These two bodies stick together. That's what purely inelastic collision happens. So these two bodies stick together and they move with a common velocity, let's say v2. So we have to find out v1 is to v2. It's pretty simple. What you can do, you can write the conservation of linear momentum, because here the only interaction happening between these two bodies and there is no net external force. So we can write initial momentum of the system, that is initial momentum of body 1 plus initial momentum of body 2, which is 0. So I'm not going to write that here, equals to final momentum of the system, means m plus n. Now the mass is m plus n times final velocity of the system. This is what happening. So what we have to find out now, v1 is to v2. So we can write here v1 divided by v2 should be 2m divided by, yes, m. So it will be 2 by 1, or v1 is to v2 is 2 is to 1. Okay. Now moving to the second question. A bullet from a gun is fired on a rectangular wooden block with velocity u. When bullet travels 24 centimeter through the block along its length horizontally, velocity of bullet becomes u by 3. Then it further penetrates into the block in the same direction before coming to the rest exactly at the other end of the block. So we have to find out the length of the block. Okay, let me draw it for you. What is happening here? So let's say this is block, and good. This is block. Which block? Rectangular wooden block. And this is bullet here. It just enters here. And at this point, it has, consider it to be a point mass. So at this point, it has velocity, and velocity is 24 centimeter. Let's say, okay, let's say velocity is u not initial velocity, and it has velocity of u exactly. So let me write it u only. So it has velocity u here, and it moves horizontally here. It is moving and moving and moving, and it comes to rest at the other end here. Let's say consider it to be here at this point, and entering at this point here. Okay, now so we have wooden block and bullet, and what happens when this bullet travels 24 centimeter, its velocity becomes one third of its initial velocity. Let's say this is a point where this bullet comes after traveling 24 centimeter. Okay, so I'm making extended bodies here, means extended bullet, but you have to consider it as a point mass. Okay, so what's next? its velocity. Its velocity becomes u by 3. Here its velocity becomes u by 3. Okay, all good up to here. Now, from here to here, there is loss in energy of this bullet, and then we have to find out first this thing. How can we find out? At this point, this bullet has kinetic energy 1 by 2 m u square, and at this point, the bullet has kinetic energy 1 by 2 m and u by 3 square. Okay. Now, what is change in kinetic energy? That is change in kinetic energy from 0 to 24 centimeter. This will be equal to the work done by the friction force between the bullet and the block times displacement, which is 24. And I am writing directly work done equals to force times displacement, because here there is kinetic friction between bullet and block. So this kinetic friction is going to be constant throughout its journey. So this is final kinetic energy 1 by 2 m u by 3 whole square minus initial kinetic energy 1 by 2 m u square. This will be minus of f times 24. I have written this in terms of centimeter only, because we are not saying it in specific units. Like if we have said that this is in joule, then I would have changed this thing 24 centimeter into meter. So let's continue with this only. 1 by 2 m u square, I'm taking common. Here it will be 9 minus 1. And then we will have minus of f 24. And then we will have 1 by 2 m u square. And here we will get minus 8 by 9. And then we will have minus of f 24. Okay, keep it as equation 1. Now, in the second case, means now we have to find out till the end from here to here. Let's say this entire length is L, this length of the block, wooden block. So change in kinetic energy, we are going to proceed in the same way. Final kinetic energy is 0, as it has been said that bullet stops at the end. Minus initial kinetic energy 1 by 2 m u square should be equal to minus of friction force times length of this block is L. Okay, then this is L. Now this is equation, let's say this is equation 2. Now we can do one thing here. We can just divide equation 1 by equation 2. So in that case, we can write minus half mu square times 8 by 9. So minus half mu square multiplied with 8 divided by 9 equals to minus f times 24. And this second equation is minus 1 by 2 mu square and equals to minus f of f means frictional force times L. So now this is pretty simple. You have here 8 by 9 equals to, here you have 24 by L, and from here you can get L equals to 24 times 9 divided by 8, which will be ultimately 27. And look, we have chosen this length in centimeter, keeping all the things as they are. Now we have 27 unit, that is length is 27 centimeter. Okay. Now moving to the next question. The potential energy of a long spring when stressed by 2 centimeter is U. Let me write it directly. Kx square by 2 equals to U. Capital here. Okay. Nothing to worry. Capital here. Now, if the spring is stressed by 8 centimeter, this is K and X is 2 centimeter. Okay. Again, the same argument. I'm not going to write any other units, just keeping this X in centimeter. So at the end, if we are going to get anything, that will mean same unit, whatever the unit here U is, means potential energy in the same unit. Okay, then next, if it is stressed by 8 centimeters. So what will be that? That will be K 8 square divided by 2. And then let's say this is U prime. And what is the value of this U prime? So we can write it. Look here. K by 2. And here is 4 centimeter square. This one. And then this value is U. So we can replace here. Look what this is in centimeter. So we can write it uh, 64 here. 8 into 8, 64. And then we can write it 16 times K by 2 or cm square equals to U prime. Look, why I have done this. I have extracted this term so that I can directly replace with U. So here we have this term and we can directly replace it with U. So the new energy means after stretching 8 centimeter, this is 16 times of this energy. Okay. Now moving to the next one. An electric lift with maximum load of 2000 kg, lift plus passenger is moving up with constant speed 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. What is the minimum power delivered by the motor to the lift in watt? Okay, so we know here this force is going to be constant. Why I am saying constant? Because to keep the lift in motion, this motor needs to give at least the force which can oppose the total force acting on the lift downward. So if let's say this is lift and this is moving with some constant velocity 1.5 meter per second, so the force should be at least balancing the total force acting on the lift downward. So what are the total force acting? One force is here due to gravitational pull. This will be 2000 kg into, look, this is mass into gravity acceleration due to gravity. Then this will be the gravitational pull on the lift. So take it 10 as it has been said in the question. Plus one more force is acting here downward because the motion is upward. So the frictional force is also going to oppose the motion. So here we have to write 3000 and now we have this thing in Newton. So, and look, power is force times displacement. So, sorry, velocity, force times velocity. So, 1.5 here we have to multiply. Everything is in SI system. So, at the end, we are going to get this power in watt. So, this will be 20,000 plus 3000 and whole thing is multiplied with 1.5 and then this whole thing is in watt. So you can calculate the energy that will be ideally radiated by this power rating transmitter in 1 hour. Okay, what does it mean? 10, no, 100 kilowatt. 100 kilowatt means 100 into 1000 watt. It means 100 into 1000 joule per second. This is the power radiation per second. Now, in 1 hour, if it is radiating power this much joule every second to get the power in 1 hour. So what is energy radiated in 1 hour? 1 hour contains 3600 seconds. So in 1 second, this much joule, in 3600 seconds, this much joule multiplied with this value. And now it is in joule only. Okay, so energy radiated in 1 hour will be this much. Okay, now moving to the next question. A ball of mass 0.1 kg is dropped from a height of 10 meter, strikes the ground and rebounds to the same height. Okay, if this ball is getting the same height after collision, it means there is no loss of energy here. Then this is a kind of elastic collision. So we have to find out the magnitude of impulse imparted to the ball. So let's say this is the ball and it falls from a height to the ground. And what is the height? The height is 10 meter. And then, okay, from here to here, it will gain some velocity. And we can find out that velocity. Here it has kinetic energy, or sorry, potential energy of mgh, means the difference between these two levels. This is potential energy. Let's say this is our reference where we are considering potential energy to be 0. So we can say directly here it has potential energy mgh. And now this potential energy is going to be appear as kinetic energy here. Means this is going to decrease and then subsequently kinetic energy will increase, and then we can say that this ball is gaining velocity. So we can say this mgh at the lowest, it should be 1 by 2 m v square, where v is the velocity with which this ball is hitting the ground. So from here we can get this v. Let's make it simple. It will be 2gh, a square root of 2gh, and then this is velocity. And we can write it directly that it should be 2 times 10, as we have to take g equals to 10 meter per square second, and this. So square root of this thing is velocity. Then what will be the momentum at this level? The momentum will be mass times velocity. And then this mass times velocity, we can write directly momentum when this ball is hitting the ground. This will be 0.15 times the square root of 10 root 2. The square root of 10 root 2, if I'm not wrong. We can take this, means here we have 10 into 10, so a square root of this term will be 10. So finally velocity is 10 root 2 and the momentum is this much. Now this is in SI system, kg meter per second. Okay, now this ball is getting rebound and then its momentum flips by 180 degree. So if we are taking this direction of momentum to be positive, this direction will be negative, and the change in momentum ultimately it will be twice of this thing. Let's say along this it is p, then along this it will be minus of p, and then change in momentum will be twice of p. So this will be 2 times 0.15 into 10 into root 2. This is change in momentum. And as you know, impulse is nothing but force times time of impact, means the time of collision, time duration actually. Very short interval of time is it. So this is delta P, and ultimately you are going to get this impulse this much kg meter per second. So you can solve it by yourself. It will be 2 into 1.5 into a square root of 2, and then it will be 3 times the square root of 2, then it will be 3 into 1.41. If I'm not wrong, it is 414 something. Okay, let's keep it up to here only. So it will be nearly 4.2 units, and unit is kg meter per second. This is the magnitude of impulse. Now moving to the next question, and this is the last question for today. The energy required to break one bond in DNA is 10 raised to the power minus 20 joule. So this much energy we require to break a bond in DNA. And we have to convert this value in electron volt. This is very simple. You can do by yourself. And electron volt and joule is related as a factor 10 to the power minus 19 joule is 1 electron volt. Okay, so I'll explain this thing later because this is in your electrostatics, which is a matter of discussion of later. Okay, so let's get back to the topic. Energy requires this much, and 1 electron volt is this much joule. So you can write it in electron volt. It should be 10 raised to the power minus 20 divided by 1.6 into 10 to the power minus 19, and just try to solve it. Whatever value you will get, that will be in electron volt. Okay, that's all for today. And from the next video, we will start the next topic, whatever be the after work energy and power.